Okay, hopefully a very short video for anyone who's trying to get a Arduino Due working with Atmel Studio, or AVR Studio, or Microchip Studio as it's called now, and an Atmel-ICE, one of those things. Here's how you connect it. Now this is a Arduino Due, but it's more or less the same as an ordinary Due. It just hasn't got a built-in programming port, it's an adapter. So you go to this 4-pin debug connector and you can see the wires I've got connected, starting from the nearest to the big chip is go black, white, grey, violet, and then I'm using this little adapter, and black goes to pin 3, red, which I've not mentioned, red's picking up 3.3 volts because it's not available on that 4-pin D connector. So red is 3.3 volts and goes to pin 1, and then the white wire, which is TCK, goes to pin 4, and the grey wire, which is called TMS, goes to pin 2 on this connector, and that leaves the fourth one, the violet wire, which is reset or NTRST, something like that. Just check that. 10 is NSRST, sorry, and that goes to pin 10, and then using the little ribbon cable goes into the SAM port, not the AVR port. And then your settings on Studio, if we go and have a look at the Debug device setup, properties, so we're using the Atmel-ICE debug, using the SWD interface. Everything else is on defaults. If I just stop the program for the moment and go to Tools and Device Programming, then you can see there that if you set it up with the Atmel-ICE, the right type for the processor, which is a ATSAM 3X80, SWD Due, apply, and then you can do read, and you'll see a device signature, and then you can look at other things like memories and lock bits and all that sort of thing. Don't need to change any of that. Now, a simple blink program. If you use pin 13, which is the LED, that's a PB27. So go for a GCC C program and it will automatically put that hash include sam.h. It'll automatically put system.init there for you. You add that line to turn off the watchdog, those 4 lines to configure the output, so it's ready to go. And then there's the under the while, the first thing makes it go high, and we've got a delay loop nested delay counting up to 3000 squared. ASM NOP is to stop the compiler optimizing away the loops, saying, well, you're not doing anything here, so we don't need to do them. And then that's the line to switch the LED low. Same delay again, another ASM NOP. If we look at the thing, that gets you blinking at about that sort of rate. If I go for, I'll go for run, and now I can, I'm going to go pause up here, and you can see we're debugging, it's showing the line we're stopped on. There's the light, and if I do the little arrow up there, where's it gone? That one. That's show the next statement. And that one is continue. So I'll show you. At the moment we're stalled. I'm going to click on that continue now, and away she goes again. And you can do all the usual things where you if you pause it, you can go to debug, Windows, and disassembly, which is nice. That's something you can't do in the Arduino IDE, or at least not very easily. Anyway, that's enough. Hope that gets some of you going. I struggled with it a bit, but got there in the end. Thanks for watching.